All right, so in this question, which you should have already tried on your own, we're comparing two runners, James, who is running on a hilly route, and Rob, who is training on a flat route. And as we read through the questions, then we could take some time to translate what we're given. We know that for James, the time to complete this loop is normally distributed, which means we can draw our cute pictures, use z-scores, all that good stuff, with a mean of 167 and a standard deviation of 25. So I'm going to use the mu, 167, and standard deviation of 25. I'm going to use those variables because it did say population here. So technically those are parameters. Whether or not we believe that's a feasible thing to have, they've given us parameters. Rob, on the other hand, the time to complete his route also follows a normal distribution with a mean of 143 and a standard deviation of 20. So the only thing we're missing to make our z-scores is that we would like to know how long it takes them each. So James takes 91 minutes, that's his observation, and Rob takes 86 minutes, that's his observation. So if we go ahead and get z-scores for both of these guys, one thing we might want to do, which I didn't do in the last problem, is do something to delineate that these are two different z-scores, right? So what we could do is use a subscript. Use a little baby j on the bottom of James's z-score and a little baby r on the bottom of Rob's z-score to kind of keep them straight. So for James, we know he's got a 91 time of his own, but this was on a course that took people 167 with a standard deviation of 25. Rob, 86, but he's on a course that took people 143 minutes with a standard deviation of 20. And here's a question I always like to ask, because the majority of students who made a mistake on this, they made a mistake at the end. Their z-score calculations are perfect. They just chose the wrong runner. Are these two guys slow or fast compared to the population? If it takes people 167 minutes to finish the course and it only takes James 91, he is really fast, right? He's qualifying for Boston. So just throwing that out there. Let's keep that in mind. I'm going to pause the video to get these calculations because I don't want to have you guys watch me type into the calculator. These are the z-scores you should have gotten. So now, if this is a test question, by the way, there's probably 4 or 5 points on this question. Usually, there's at least a point for each of these, and then there's a point for choosing the right answer and at least 1 point for giving me the correct reason. It doesn't say that on this one, it just says who's in better condition, but I usually ask who is in better condition and explain why using z-scores or the empirical rule or a drawing or something like that. So in this case, who's our better runner? Like I said, most students make the mistake right here. Our better runner is James. Because like we just said before, lower is better when we're talking about running times. So the fact that he is further below makes him the better runner because his running time is further below average. So with the unusual questions, you're looking for further from 0. And for the better questions, because there's always a question about better, that's going to depend on what we're talking about. So if we're talking about running times or golf scores, lower is better. But if we're talking about an exam score, higher is better. So you have to pay attention to what we're talking about in order to get this question correct. So like I said, this would be another point saying James, and then this is at least 2 points, having something to explain you really understand what you are looking for with those two z-scores.